Grade 12, Lesson 2, Advanced SQL, Part 1. Good day everybody and welcome to the second lesson of Grade 12 Databases. We will look at the first part of Advanced SQL. Let's look at the contents of this video. We will look at the following terms, specifically the join and the join condition. We'll then look at the types of joins, specifically the inner, full outer, left outer, right outer, and cross join. We will then look at some examples. Let's begin with the terms. A join. Joins are used to combine two or more tables on an established relationship. If you're unsure what a relationship is in a relational database, please see our video regarding relationships. Joins are useful to retrieve a result from two or more tables. So if you want to pull data from one table and on another, when there's a relationship between the two tables, you would use a join. Let's look at the join condition. This is the condition a record needs to meet for it to be able to be joined, to be added to the join. So let's look at the types of joins. We've got an inner join, which all the records in the result meet the join condition. Most used in high school. So this join is mostly used in high school, and we'll see just now why that is so. Here's a graphical representation of an inner join, where the little green part in the middle is the inner join. Let's look at the full outer join. The full outer combines the left outer join and the right outer join. Returns rows from both tables where join conditions have been met. So as you can see, both tables are green, so it returns all the rows from both tables where the join condition has been met. Okay, let's look at the left outer join. This combines all of the rows in the left-hand table with all of the rows in the right-hand table that meet the join condition. So here's a graphical representation. So the left outer join, as you can see, the left-hand table, table A is green, and including the intersection part as well. Let's look at the right outer join. This combines all of the rows in the right-hand table with the rows in the left-hand table that meet the join condition. So it's the opposite of the left outer join. There's a graphical representation where you can see table B, the right-hand table is green, including the intersection part. Let's look at the cross join. The cross join is also known as the Cartesian product of two tables. The Cartesian join returns all of the rows from table A combined with all of the rows in table B. Here's a graphical representation. So A1 is combined with B1, B2, B3 to make 3 new rows. A2 is combined with B1, B2, B3 to make another 3 new rows. A3 is combined with B1, B2, and B3 to make the last 3 new rows. So as you can see, it makes a very big set that returns. Okay, a note on joins. Inner join is the only join that will not have null values in its result. Thus is why it is used in high school, as it does not give you any nulls. Whereas all other joins may have null values in the result. A null value is when the value for a field in a record is not known. In other words, it is an empty record. Let's look at the example. Join employee and tax group on employees tax group ID field and tax group's group ID using the following join types. So we will use a cross join, a right outer join, a left outer join, a full outer join, and an inner join. Here's the design of the two tables. So there's our two tables, our tax group and our employee with each of their own properties. We've got the relationship going from group ID, which is the primary key of table groups, to tax group ID, which is the foreign key of employee. This relationship is a one-to-many relationship. Let's look at the example. And here we have an example. Now, firstly, just as a note, unfortunately, Delphi does not like a cross join or a full outer join. Fortunately, it gives an unspecified error, but I am going to show you the syntax for how to do it if you do want to test on something like W3 schools, which I highly recommend you do. Go practice SQL on there. But I will show you how the syntax will look for a cross join and a full outer join, just so you can see it, but just please note that it does not always work in Delphi. The right, left, and inner join, on the other hand, always does work. So, let's look at the code. So here we have the cross join. So as I said here, Delphi gives an unspecified error with the cross join. So what you would do is you would say dm.query SQL.close. If you're unsure what dm and query SQL means, please have a look at our video on how to connect a Delphi and a database for SQL. Okay, so now that we've done the close, then we say .dm.query SQL.SQL.text, and here we place our SQL statement will go in here. So for a cross join, you say select all from employee, cross join it with tax group. Now please remember that's from our notes that we went through just now. That is our databases or our tables in our databases. Then we would say open, and then it would execute the query when the button is clicked. Same with the full. So you will say dot close. Then in the statement, you will say select all from employee, full join it with tax group on employee.taxgroup ID. So this is the foreign key from employee that references tax group equals tax group.group ID. This is the primary key for tax group, and that is where the relationship is based on, is on the foreign key from employee to the primary key from tax group. Again, fortunately, full does not work with Delphi, so let's move on to the next one, the inner join. This is the one most used in high school. It's the easiest one, and it will always give you full values, not null values. So we say select all from employee inner join with tax group on employee.taxgroup.id equals taxgroup.groupid, where the tax group ID is the foreign key and the group ID is the primary key. And then for the left, you'll say select all from employee left join tax group on employee.taxgroup.id equals taxgroup.groupid. Same as before, all that differs is it went from inner to left join. Then lastly, the right join. So you'll say select all from employee, right join with tax group on employee.taxgroup.id equals taxgroup.groupid. So let's have a look at how the output will look for these three. So if we run it, pull it over, so we'll say right outer. Here's our right outer join. As you can see, if you're unsure this is a DB grid, please have a look at our first query, a simple SQL statement video, explains how to connect a DB grid. So if we pull it over, here's our tax group ID, and there's our group ID from the tax group table. Then for our left outer, same thing. There's our group IDs. As you can see, they are the same. But please notice the difference in IDs, how it ranks these IDs between the right outer and the left outer. And then the inner join also has its own ranking as it joins the two together. And then just to double check, our tax group ID equals the group ID. So that is all. What I do highly suggest is you go onto W3 schools, their SQL section, and go and look at the joins there and play around with their mock databases. they do have there. I highly advise it. It's quite a lot of fun to go play around there to see how all of these joins work in a bigger database.